So I'm introducing our next speaker, Pavel Fedotov. Yeah, you're on now.
Okay, so the topic of my presentation, okay, I hope the camera works, is the zero-knowledge proofs on Mina, zkPassport, and SoulBound NFTs. So, like, the slides are available if you scan the QR code. You can actually get an access to the slides. And I've compiled the resources in the comments on Google Docs, so you can actually research it further. I'm just not sure if they're like people that are really that much interested in this topic. But yeah, I've compiled it for you if you actually like enjoy this. So here's my introduction. I'm an elected member. Okay, let's just open the slides as well here. Oh no. I was actually like an elected member of Arbitrum DAO Mini Grants Council, where we sponsored starting projects, very early stage projects on Arbitrum. There were like I think there were like 4 projects each week, running for 8 weeks straight. And we've actually sponsored the community in Venezuela that is not only suffered from coronavirus, but from everything, I guess. And we've actually sponsored them with food, with education, and we are very proud of it. And this experiment was actually running for free, and electors were actually paying Arbitrum funds to vote. And we've elected this project. And again, we're very proud of it. So aside from that, I'm a founder of PinSave, which is a decentralized Pinterest. We've got some funds from Optimism in retro grants with Greg, and I'm building myself a Mina version of it, running simply on zk smart contract instead of EVM. Yeah, so we're definitely looking to applying for retro grants, but the topics have changed and we have to adapt, right? So the last zk Ignite project funding program consisted of about like 2 million in Mina, which is roughly 2 million something in US dollars. So you're more than welcome to apply in the next cohort as well. So please listen to this presentation if you want to apply. So this is my, I guess, portfolio on Arbitrum. I've got like a lot of votes actually. I've got 30 million in Arbitrum, which is about, I think, like 20-something million US dollars in procurement elections, right? I've got the great feedback from Disruption Joe and from other delegates. Yeah. I've actually like founded another blog, which I've delegated to my brother who runs it instead of me right now. And yeah, so yeah, so the actual topic of my presentation is zk, right? And I think like the selling point of the zk and SoulBound NFTs and zkPassport, which is a sort of derivative of SoulBound NFTs, is that Web3 currently lacks foundational components to depict social identities. And this is where the non-utility tokens come in. So, for example, currently we have wallets or like centralized exchanges, right, that totally control your the way you can actually spend money, and there are no transparency in how they actually store your funds, right? And the SoulBound NFTs can help with managing your identity and providing more transparency, for example, with regulators. Okay. So the SoulBound tokens are non-transferable, and this is the key feature. So the core thing you should remember if you're new to zk is that we have a verifier and we have an issuer. So verifier is is a program that just verifies if your credential is real or not. Simple as that. And an issuer is somebody who actually issues an attestation, something like you've graduated from university. Simple as that. Okay. So now we're moving to Mina zk blockchain, which is the very first, guys, the very, very, very first zk blockchain, and it's actually has a fixed size of 22 kilobytes. So the zero knowledge proofs enable to balance scalability, decentralization, and security within the Mina protocol. And this is, again, this is a unique selling point. And this is also very, very, very vital because currently EVM depends on programs, not on programs, but like on APIs such as Infura or Alchemy, right, which totally control the way you interact with the whole ecosystem. And on Mina, you save so much in storage space, you save on transparency, and it's definitely more efficient than EVM from this perspective. So this is a life cycle of a Mina transaction and economics of a Mina transaction. In this case, we actually have a block producer and we have a snarker. So what allows us to save on space? We don't have to verify like a large block, right? It's just like a transaction. And the core thing of zk snarks is that they're associative, meaning that you can just like snark simple transaction and that's it. But the more technical details, again, are available on Mina white paper, and I've actually shared more details in the the slides. If you're if you want to argue with me, but definitely I'm not giving a 100% perfect explanation. Sorry. So, for example, the real world use case which Mina is actually trying to build. And we are very interested in building with zkPassport, right? And like a passport, if you look at it, usually on the back side, right, has an NFT chip, and this chip has an encryption, an active encryption system. And what should allow us to read this passport data is the NFC chip, and somebody actually having an access to a code that decrypts this information, right? So we're trying to actually build the use case for normal things like passports, right? Where everybody has passports, or nearly everybody has passports. And the Mina is actually is a connection to it, or an API. So here is the RFC zkPassport, right? You can go through it. It's not finalized yet, but we're working on completing it. So yeah, the zkPassport, with zkPassport, you should actually prove facts with your identity, such as nationality, age, your address, to get an actual airdrop. Yeah. In a more, I guess, legal and transparent way, because for example, regulators want to ensure that you are actually giving an airdrop to a unique person. And this is one way of actually completing this with passports and moving it on chain with verifiers and issuers. Okay. So yeah, this is a more in-depth slide on how to use this application, but there are definitely more than two scenarios, such as proof of nationality and proof of uniqueness. And just to scare you guys into believing into zkPassport, is that 1 in 3 documents cannot actually be verified for authenticity. And this is the slides from ICAO, which is an actual organization that works on scanning your NFC chip, right? And yeah, they cannot actually decide if it's a defect or a fraud. And again, I've linked the slides to the link to the slides, and you can verify it for yourself. So yeah. Okay, so I've actually I've completed a proposal on zkIgnite cohort 3, and I've asked to build SoulBound tokens, but the developers did it themselves. And this is the link to the SoulBound tokens on Mina, if you're curious. I'm just going to basically show you the methods. So yeah, it's just read-only, you cannot transfer it. But what you can do is you can deploy it, you can initialize it, you can verify it, and that's not that difficult, right? And now I'm gonna tell you what I'm actually working myself on, and I'm working on PinSave, decentralized Pinterest. Very, very simple. But I think from the technical perspective, it's an extension of SoulBound tokens, but instead of just attesting things, I'm building more of a transferable version of it. There are only 8 states available on Mina smart contract. We have the events as usual. We have the field, which is a property of actually zk things. So instead of normal mathematics, we have modular ones, and we can totally do the similar operations with the fields as with normal things. It's just you have to write a field. And for example, the difference between uints and fields here is that uints actually store less. Yeah, so it's more efficient to just have an array of uints, for example, rather than the field. And in this case, public key takes 2 fields, or 2 storage spaces. So the deploy arguments starts when you actually deploy a program. Init works with deploy, but it's not necessary, and deploy is necessary. Then you have, in my contract, we have init root, which initializes a collection, right? So for example, you could just simply initialize a collection and not update it. It's a very, very simple NFT collection idea, right? But what I've done is I've added a function to add more NFTs to a collection over the time, right? So I have init NFT, and we have a mint NFT, which actually mints it. And then we have a normal transfer function, which you can use to transfer the tokens. Yeah, we have yeah. Okay, I guess this is this is advanced. Okay, so this is actually a custom. This is a custom data type, I guess. But I can explain it in more details. But I guess the proper way to say it would be a custom data type. This is a struct. And we don't really have to initialize it on the contract. We can just pass it to the method, and the method can verify that you've passed the correct thing. That's all. You don't have to store it anywhere other than your local database. Right. And this struct has things like name, description, ID, CID, owner, and is minted is just to ensure that on your database, local database, you've actually stored, you can quite easily find minted and non-minted NFTs. And you don't really have to worry about the amount of space, right? Because you just pass it to the contract executes it, that's it. Yeah. and it's much more easier to just kind of use the inbuilt methods, the methods you've created in the struct within the contract, right? And you can use the same struct in different contracts. It's just like it's a standard. Yep, this is the main function in more details. So right, we've verified that you have an actual access to the to run this code. Then you verify a tree leaf that is actually that you're accessing the latest state of the app of the smart contract, right? Then we assert that it's not minted. Then we change the state of a struct to mint. Then we've actually compute root and the key for the newly created, the updated app state. And afterwards, we've actually sent the items to a person that sent this request. So we update the total supply, the state, +1, right? And we update the roots, which we just computed. And that's it. It's difficult to adapt to this, but it's digestible and it's much more efficient. So these are the functions that I'm using to deserialize and just interact with the database. And for the sake of simplicity and just because it was very, very easy, I've used Redis database from Vercel, and it runs very, very well. I don't really have much complaints other than I'll probably have a very, very large bill to pay at the end. And this is the demo, which is actually deployed to Mina. You can click the link. It might work, but you have to install the wallet, and you'll have to wait for some time before the contract actually compiles. It's about 20 seconds. But it actually ensures that the app is safe to use. You don't have to worry about auditors and scammers. Yep, these are my links, and if you have any questions, I'm more than happy to answer.
Do we have any questions for Pavel in the last couple of minutes? Yes, please.
What are the advantages of Mina compared with, I don't know, stuff like TLS notary? Because my understanding might be bad is that Mina is self-contained state, doesn't have access to external ETH state or web state or whatever.
Yeah, exactly. So we have. Okay, so I think there were a bunch of RFCs, right? So I'm not really working on, I'm not working in Mina, right? I'm just building stuff. And it just so happens, right, that Mina is the thing that I feel comfortable using, right? With, for example, Circon. There are a bunch of stuff that I'm no documentation whatsoever, right? I've used Stack Overflow, right, to ask some questions, and I just get downloaded for nothing. Yeah, and on here, I can just ask questions on documentation. I get reply on almost instantly. It's just that sometimes they're "Why are you bothering us? You just keep asking too much questions, too many questions, right?" But from the perspective of connecting to APIs, right? You can probably still you can deploy, right, an app with a certain state. So for example, I'm not really sure how the APIs are connected on Ethereum, right, on TLS notary. I'm not really sure, but from my perspective, it's more of okay, here is an updated link, right? So they store a string, right, and then the string gets updated. But this is not really a direct connection to anything. And so in that kind of sense, there should be a way, and you should build it. Exactly.
Any other questions in the room? Anything you want to know about zero knowledge? Now's your chance to ask. Yes, please.
In terms of scaling PinSave, is Mina protocol the best option, or would you be looking to also build and extend that somewhere else?
I think, to be honest, what I'm building is more of an experiment, right? So, for example, the version that actually got funding from Optimism, it used Ceramic and used Orbis, but what it requires an access to MetaMask, and it doesn't really have that much of flexibility for me as a developer to configure it. Yeah, and what I'm actually doing is building just tools that are like, for me at least, is like a very easy to use. And I've noticed like the database, centralized databases, unfortunately, is much more easier to use than, for example, IPFS right now. I'm not complaining. I'm just saying like I don't want to overwork myself configuring stuff. If it works, like the normal tools that you use in your developer day-to-day life, right? You like work like database. If you're still gonna have like a cache, right, for NFT marketplace, why don't you just I don't know, right? Build it with centralized data tools and just ensure that you share, that you store the data. Here's the data. That's all. And this is a way to verify that the data actually is valid.
So just verifying state transition.
In a way, yes. Again, I'm not a technical person, so you should definitely go like on Mina docs, go to like GitHub repository and ask as many questions as you want. They're very like friendly, and I'm just like, sometimes I'm like, I will like dive deeper into research area just to make their life much more easier.
Any other questions for Pavel? Don't be shy. Going once, going twice, going 3 times. Thank you so much, Pavel. Give it up for Pavel.